Hi, in this video we're going to take a look at exponential equations and how to solve them. We're going to break this section up into a couple of videos for time purposes. So an exponential equation is an equation involving exponential functions, such as 2 to the x power equals 128. In other words, what power do we have to raise 2 to get 128? Well, we have to raise 2 to the 7th power to get 128. And while we could check that by trial and error, especially helpful when the answer for x is an integer, oftentimes our answer for x is going to be an irrational number, which means that we'd spend way too much time trying to just guess and check to get the right answer. Such as if we had something like 2 to the x equals 129, because 129 is slightly bigger than 128, our answer for x is going to be slightly bigger than 7 for this particular problem. So we have a general technique for solving exponential equations, and if possible, we want to try to isolate our exponential function. So in the last slide, 2 to the x was already by itself, which is good, but we might have to do some cleaning up on that side in order to make that happen. So if convenient, we could try to express both sides with a common base and equate the exponents using the equality property for exponents. But more often than not, and a more general strategy is going to be to take the logarithm of both sides. And I recommend using the same base for logarithm as you have as the base for your exponential function. So for instance, 2 to the x equals 129. If we take log base 2 of both sides, because we do have 2 as the base for the exponential function, log base 2 of 2 to the x equals log base 2 of 129. That's our equality property for logarithms. And then log base 2 of 2 to the x power is just x. X is going to be log base 2 of 129, which is slightly more than 7, as I mentioned earlier, about 7.0112. So example 1, solve each. Round your answers to 4 decimal places. So we have 2 to the 3x equals 16 to the 1 minus x. Now, in that last slide, we said if possible, try to write the bases as using the same base with maybe different powers. So for instance, 16 is 2 to the 4th power. So we can write this as 2 to the 3x equals 2 to the 4th power being raised to the 1 minus x power. And then using our power property for exponents, we're going to multiply 4 times 1 minus x and get 4 minus 4x. So now we have equal bases. Our exponents have to be equal by the equality property for exponents. So we can set 3x equal to 4 minus 4x, add 4x to both sides, and then divide both sides by 7, and we get x's 4/7 as an exact answer. Approximately 4/7 is about 0.5714, but exact answers are always better because then you can just leave it up to the other person to figure out how many decimal places you want them to round to. As an alternative to what we just looked at, instead, we could take logarithms of both sides. And I recommend, as far as the powers or what base you should use, 2 versus 16, I just use base 2 because that way we won't have to worry about getting any negative numbers involved. But we could have just as easily taken log base 16 of both sides. Log base 2 of 2 to the 3x is 3x, or we could just bring the 3x down and get 3x times log base 2 of 2, and then using our power property here, 1 minus x times log base 2 of 16. Well, log base 2 of 2 is 1, so we get 3x times 1 is 3x. Log base 2 of 16 is 4, because 2 to the 4th power equals 16, so log base 2 of 16 is 4. So we have 3x equals 1 minus x times 4. That gets us, when we distribute the 4 to both terms, 3x equals 4 minus 4x, which we saw will give us x equals 4/7. So if you can get the bases to be the same base with maybe different powers, go ahead, but it's not the only way you have. All right, part B, we have 2,000 equals 1,000 times 3 to the negative 0.1t. Our exponential function is 3 to the negative 0.1t, so it's being multiplied by 1,000. Our first step is to divide both sides by 1,000 to get our exponential function alone. So 2,000 divided by 1,000 is 2, and we get 2 equals 3 to the negative 0.1t. So because I can't think of anything to write 2 and 3 as to have the same base, just take the log of both sides And since our base for our exponential function is 3, I recommend using log base 3. Now, log base 3 of 3 to the negative 0.1t is going to equal negative 0.1t. However, you can also use your power property to bring that negative 0.1t down, and we have negative 0.1t times log base 3 of 3. Well, since log base 3 of 3 is 1, that's just going to give us negative 0.1t times 1, or negative 0.1t. So we could make this a lot shorter if we recognize that log base 3 of 3 to the negative 0.1t is just going to end up equaling that exponent of negative 0.1t anyway. But we have log base 3 of 2 equals negative 0.1 times t. So if we divide both sides by negative 0.1, we'll get about negative 6.3093. So log base 3 of 2 divided by this negative 0.1 is about negative 6.3093. All right, so that about does in this video. Thanks for watching. I'll see you next time.